Again, the reason we're doing Unit 3 quiz as a quiz is not because it's not an important assessment or an end of unit assessment. We wanted to make it shorter and less time, so each topic didn't count for as much percentage, and therefore you won't like completely blow out your test if you don't understand one thing, because you would have to have like 10 questions of a single topic, right? So please take it seriously. There is a review on your modules. So you guys are on the B day that happens on a Monday. So you have to look at last week's module titled October 2nd and this week's to see stuff. So make sure you look at both. So for example, here, so this is last week's module at the bottom. See all this huge module at the bottom here. You see that there's async activities for today. Do we see these? Yes. Yes. Okay. So you have to do these still, but at the top here, I showed you, okay, before the quiz, you need to do this. Okay. So it's because you guys, your B day landed on a Monday and it's weird in the way the week is split up, but make sure you look at both. The Unit 3 quiz is here. Please take it seriously. If you need help, let me know. I am here after we hang up every single class with my Zoom, and I can tutor you if you are like completely lost. So please hang back if you need me. Okay. Any questions about that?
Is the quiz going to go in this first 9 weeks, or it's going to be in the next 9 weeks? Okay.
This one. Yep. If you have something on Wednesday, Maddie, I think it's this 9 weeks. You can either, so Maddie, you can either take the quiz early, like with an 8A class, or like I can open up for you on 8A and give you the thing so you can just come attend one of those classes, or you can do it with the testing center. Okay. If you guys ever have, like, if you know ahead of time, like for this example, I have a tournament for whatever sport and I'm not going to be in class on a test day, please let me know ahead of time instead of just not showing up. It's much easier to plan. Okay. That was perfect, Maddie. Thank you. So are there any logistical questions? Okay. No logistical questions. Sweet. Okay. Fun announcements. I forgot, you know, my little pen thing I use all the time. I left it at home because I used it at the college this weekend. So I'm drawing everything with a mouse. So my handwriting is going to be slightly rough today. I've found that I'm not as accurate with a mouse, but it's going to be fine. Everything's fine. It's going to be great. Y'all are going to love it. Okay. So we're going to do polonium, PO, all the way over here. All sorts of things on the periodic table. Going to be great. Let's do the name wheel. Who am I picking first? Oh man, I uploaded the name wheel for 7th period. I was like, that person's not in here. Hold on. I'm so bad at that. I'll always click the wrong one. Okay. Wajia, you are lucky number 1. Okay. What do we have to do first before we do anything else?
Find polonium, or
Yep.
like mark the periods.
Yep, we found polonium. We need to mark the periods. And what else do we need to do? Who is in the wrong place at the wrong time?
I don't really know. That's kind of all I did.
Okay, so what's an S? Tell me the 2 elements in one S.
Oh, hydrogen and helium.
So why is helium in the P block?
Because of the valence electrons.
Right. So where do we need to put helium?
Over on the S block.
Yes. So helium, we cross it out, we move it to the S block. I think you already did it and it was so automatic, you didn't even know what I was asking, which is fabulous. That's the best thing I've heard all day. Okay, so that's great. So thank you very much. Next, we label the blocks like you said. So we have the S, the D, the P, and the F. Okay, so Sangeet, what do we write above these? We have S, right? Which one of these are different? We write an S above this one. What do we write above the blue one?
Above the blue one would be P.
Okay. What do we write above the green one?
The green one is D-1 because it drops.
You did it. Yes, it's D-1 because it drops by 1. Love it. And then the pinky purple, I can't really tell what color it is. I guess it's kind of purpley. It's just very bright on my screen. It's like, Genevieve, said it right. What do we do here? What do we put this one?
F minus 2.
F. See, I'm drawing with my mouse. It's a little rough. F minus 2. All right. So S, P, D minus 1, F minus 2. Love it. All right. Come on. Next, I need to start writing my configuration. So Lucas, take me through this configuration. Tell me what I write. Where do I start?
Do you start at hydrogen?
Yep, and that's energy level 1. So what do I write first?
1s2.
1s2. Okay. And what do I do next? So that's these two. What do I do
Then
next?
2s2.
Then 2s2. Oh, this is doing better than the last time. All right, what's next?
Then 2p6.
Yep, 2p6. It stayed 2 because we're not in our weird gated communities of D and F with their weird grass rules, right? I mean, electron rules. Next.
And
I'll let you stop
then
after 3.
3s.
There we go. 3s2.
What?
I said I'll let you
Yeah,
stop
yeah.
after 3. I'll give someone else a turn. And what's this one? The last part of 3.
Okay. Is it 3p6?
Yep, it's 3p6 because we went through all 6 boxes of the P. Dun, 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 dun. All right, next person. Eva, what do I do next?
Next you would do 4s2.
Love it. 4s2. Oh, it takes so much longer with the mouse. All right, now what do I do?
3d10.
Yeah, so technically Lucas should have gone through the D block, but I wasn't gonna give the spoiler away, right? 3d10. Remember, because we drop by 1 when we enter the D block. We go into the gated community, we have to subtract by 1. When we leave that gated community, we stop subtracting by 1. So what do I write for this one, Eva? Last one I'll ask you.
4p6.
4p6. Love it. Next person. Sia, not Saya, Sia. Sia G.
Hi.
Hi, how are you?
Good. How are you?
Said that so conversationally, I couldn't help myself. Oh my goodness. Okay, what do I write next?
Okay, so after 4p6, it's 5s2.
Yep, 5s2. All right, then what do I do?
And then you go back, so it'd be 4d10.
Yep, 4010, because we're in that weird gated community again. Okay,
Mhm.
4010. And then what?
And then 5p6.
Why is it doing this? It hates me. Okay, 5p6. We went back up because we left our gated community. Okay, so that was this one and this one. All right, now we get to this last funky row. I'm going to give someone else a chance. Remember, it's going to get funky. Maheen. Maheen, what do we do now? I'm going to start a second row, guys, just for visual sake, but remember, you do it all in one line, okay? All right, what do I do next, Maheen?
We do 6s2.
We have 6s2 because this is 6, right? Then what do I do?
Then we do 4f14.
Oh, that was so beautiful. Yes. Yes, we remembered because even though we think we're crossing into this block, we're not. We have to go down here. This one's actually LU, remember? And so this is 6 minus 2, which is equal to 4. And that's where she got the beautiful 4f14. Oh, love it. So good. So good. Wait. No, don't lose it. No. Keep. I'm going to keep them. Hold on. Oh, please stay. Oh, yes. Okay. Whew, that was scary, guys. Oh, that was like worse than a horror movie. Oh my God. Okay. All right. 4f14. Good. All right, now what do I do? Sorry, that was very dramatic.
And then I got 5d10.
5d10 because we're only subtracting by 1 in the D block, right? So here it's only 1 down. So that's where it got the 5d10. Love it. And then, yep,
Mhm.
Go ahead.
64.
6d4. Okay. All right. Give me a scale of 1 to 10 on how that feels. In the chat. Remember, you can always send me stuff privately if you want to. All right, lovely humans. How many of you love it when I assign you one of these on the bottom right part of the table and you're like, oh man, I'm going to get to write so much. I'm so excited. Is that how we feel? Are we just like, oh my God, I'm going to get to write all the letters. I am so stoked, right? No, that's not how we feel. How would you like it if there was a way you didn't have to write all that? Wouldn't that be nice? If you watched your notes, you learned there was a way. So let me show you the exact same one. Oh, is it not gonna let me erase it now? Shut up. Okay, hold on. We're just gonna go backwards then. Ha, suck it. All right. So we have this guy. Let's do the same one again. Okay, let's do the same one again. So what did we notice about every configuration we've done? Who's next? Carter, what have you noticed about every configuration we've done? Is there a pattern that you see? Carter, are you here? Trying to look. Milan, what about you? Are you here?
Yeah.
All right. So now that we have this, what have you noticed has always been the same? Oh, Carter, that's okay. We'll come back to you, baby. Thank you for letting me know. What have you noticed has always been the same every time we started?
The helium always goes to the S.
Helium always goes to the S, and when we start writing our configurations, what does it always start with?
The period number.
Yeah, it's always starting with at which element? Which element does it always start with?
Hydrogen.
Right, and we always start 1s2, and the next one is always 2s2, and the next one's always 2p6 because we're filling in a specific order. So on that last one, I needed 2 full lines because there was so much stuff to write. But what did we say was cool about noble gases, Kai? How are noble gases unique?
They have like all their electrons filled up.
All their valence electrons, their S
Yeah.
and their P orbitals are completely full. So they are like a fully satisfied line, right? So what we do is we can look at, okay, if I want to do polonium, I go to the noble gas that is above it and to the right. So I would go to xenon and I can write xenon like this. What that means is that I am using the electron configuration of xenon and then building from there. So instead of that whole big line, it would just be Xe, and then I would start here on the 6th level. 6s2, 4f14, 5d10, 6p4. So instead of writing all of that, you can just go, oh, it's going to be the same up until xenon, and then this last energy level is where it's different. How cool is that? It's pretty bomb, right? So all you have to do, so if you want to figure out which noble gas to use, let's do this. Okay, erase all. All right. Trisha, if I want to find the configuration of tin, which noble gas do I use for my notation?
Is it K?
Keep going. Say it with confidence. Do it again with confidence. One more with time with feeling. If anyone knows that reference, I'll be really happy. Once more with feeling.
Krypton.
It's krypton because we went up and all the way to the right and we found krypton. So our configuration would involve krypton. And then we would go to the line. So we'd say 5s2, 4d10, 5p2. So much better because we don't have to write everything up until krypton. Okay. So now let's see another one. Kira, if I wanted to do bromine, which noble gas would I use? If I wanted to bromine, which noble gas would I use?
Argon.
Argon, good. If I wanted to do magnesium, which noble gas would I use? Dia.
Would it be neon?
It would. You would go up and all the way to the right to find neon. Love it. Let's see, Carter, are you ready for me to come back to you?
Yeah.
You radium. Which noble gas would we use for radium?
Radon.
Radon, right? We go up and to the right. And then, so what we're doing is we put that one in brackets saying we're using the configuration of radon, and then we're at 7s2. And that is so much shorter than writing 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, and then 7s2. Oh my God, right? So this is really helpful, but you have to know how it works before you start. Thank you, Carter, for letting me come back to you. All right. So how does that relate to what we're doing now? Let's go to the next one. Okay. Or electron orbital diagrams. Okay. We kind of looked at this a little bit, but we have rules for how we fill the arrows. So a couple of things. Electrons are arrows. Okay. We represent them with arrows. So every single arrow is an electron. Notice how this table is blank. You don't have to know the name of the element to know the electron configuration you're looking for, right? You just have to fill in the blanks because we're using the blocks to count. So I want you guys to dissociate from looking up a name and thinking you need that, thinking more about the shape, okay? So for example, if I was doing this one right here, I know the configuration is 1s2, 2s2, 2p3 before I ever know that it is nitrogen. Okay, you don't have to know that, all right? So I'm going to do some examples, okay? When we're doing electrons, electrons are equal to arrow. Let's say we have 9 electrons. We're not even going to worry about the periodic table yet, okay? I'm just telling you, we have 9 electrons, okay? This is our orbital filling. I'm going to have you guys writing some of these out here shortly. So you practice writing the lines. The first one, we're not going to need very much. So just go up to, let's see, just go up to 2p. Okay, go up to 2p on your own. So draw on your paper, 1s with a line, 2s with a line, 2p with 3 lines. Okay, so Gus, does energy increase as we go up or decrease as we go up for the orbital diagrams?
Energy increases.
Yes. So as we move up the diagram, okay, our energy is increasing. Oh, this is so rough writing with the mouse. Oh my gosh. Okay. Energy is increasing. Sorry, it's going to bug me if it's like that. I'm trying. I'm a flawed human. Okay. Energy goes up as we go up. So we have to start at the bottom and work our way here. So the joke that I used to use when that song came out was that we started at the bottom, now we're here, you know, like if you think of that in your head, that will help you with this. So you always have to start at the bottom and then go to here, okay? Each line holds how many electrons for those of you that watch the notes? Jessica, let's hope you watch the notes.
Each line can we hold 2 arrows?
Boom, got it, love it. Each line only holds 2 electrons, and this makes sense. On our periodic table, How many electrons does 1s have? Hold up with your finger, guys. How many? 1s has 2. Guess what? Each line holds 2. So this matches exactly what you already know from the periodic table. Okay. So I'm going to draw my arrows like this and like this, because 1, I'm using a mouse, and 2, that's kind of how we do them in chemistry, even though they're weird. So electron arrows, we draw like that kind of. You can do a full arrow if you want. It's just way harder for me to do with the mouse, okay? Can we ever put 2 of the same type of electron in the same orbital? Renee? Knowing that lines are orbitals. That's what the name of the line is.
Wait, sorry, what was the question?
Can I put 2 electrons of the same type? Can I do an up and an up electron together, or a down electron together?
No, you cannot.
No. So we always have to have up and down paired together in one orbital. Okay. Opposite spins. If we have the same type of electron and the same same type of electron and the same spin, they will not like to be in the same room. Like electrons repel each other, the same spins, okay? So just be clear, you have to have opposite spins. Arrows represent electrons, and electrons have an up spin or a down spin, okay? The reason they need to spin to be close to one another is because of what they're made up of on the quantum level, but we don't do quantum chemistry until AP and IB. So if you go to AP and IB, you're going to unpress the I believe button and learn why. But if you're staying in pre-AP and for right now this year, we're going to say, yes, Miss Longley, and press the I believe button because I said so. Okay. So we are doing an up spin and a down spin. Okay. So if we have 9 electrons, I start at the bottom and I draw up spin, then down spin. That is all of the electrons I can have in 1s. That is the same as drawing an up spin and a down spin. Does that make sense? Seeing it on the table. All right. We haven't finished yet. We have 9 electrons. So now I'm going to draw an up spin, then a down spin. So now I've done up spin, down spin. Okay. Is it making sense? Scale it. Thumbs up if you're getting it. I know I'm going a little slow, but it's because it's weird. All righty. So next we have 2p. So this is where it gets funky. Okay, if you had a field trip, pretend 10 of us are going on a field trip. We're going to NASA. We're going to do some space stuff. It's going to be awesome. And we go down to NASA and I have 5 hotel rooms. Am I going to put all 10 kids in the same room? Am I going to put 4 kids in one room and a single kid in the rest of the rooms? So like one of you has to share with 3 people and the rest of you can have your own room. Does that seem fair? No. So what we do is we fill each room with 1 person and then we pair up as necessary. Does that make sense? So we do the same thing here. Now, when you finish your electron configuration, I'm not going to know looking at it necessarily if you filled it the correct order every time, but I'm going to, remember I told you that thing about building habits and how we build habits and we learn how to press the jump button and the run button before we do the weird stuff, right? Always fill it in the right order. It will make it so it's a habit so you don't have to remember to do it at the end. So when I fill this, I'm going to go up, 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 and then down, down, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's all 9 electrons, okay? The way this looks is notice how P always has 6 electrons, right? If I have to pair those electrons in groups of 2, that means I have 3 orbitals, right? So I go 3 blocks. It's basically cutting it in half. So when I fill the P orbital, I would fill it up, 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 down, down, down. Now, when we get to quantum in AP or IB, you're going to learn that those up and arrow down arrows aren't exactly in that order, but we are using this as a representation to remember the orbital rules. So don't worry about the order of the arrows, okay? We have 3 ups before we have 3 downs, or 2 downs, just like we drew it here. So sorry. So we did the configuration for fluorine. Okay, we had 9 electrons. We did the for fluorine, and our configuration is 1s2, 2s2, 2p5. 1s2, 2 arrows, 2s2, 2 arrows, 2p5, 5 arrows. 2 plus 2 plus 5 equals 9. All these should be cooperating. I have 9 arrows in my periodic table. I have 9 arrows on my diagram. All of my exponents add to 9. I was supposed to have 9. Okay, I know we're going a little slow, but I'm going to have you guys try one on your own now, and then I'm going to have you try one in a group that's more difficult, okay? So, erase all in God's slide. Beautiful. Okay. Okay, Darshan, are you here? Yes, I saw you, I think.
I am here.
Awesome. Okay, hold on one second. Pause, Darshan. I'm going to come right back to you. So, Dia, I had a question actually from 3 different people. Can you explain why I did 3 up arrows and then 2 down arrows? Yes, because when I got to here, okay, remember I have to put 1 arrow or 1 electron in each orbital before I pair them up. Electrons don't like each other, so they would rather be alone than paired up. They're the same charges, kind of like when you have the same type of magnet, like a north magnet and a north magnet, they repel. But if you force them together, they'll stay close to each other. They're not going to touch, but they're going to stay close to each other if I force it to, right? So the way electrons fill is they don't like each other. So they're going to try to be in different rooms until every room is full, and then we're going to pair up. So if I have 9 electrons and I used 1, 2, 3, 4, 5, 6, 7, then 8, then 9. Okay. If I had 6 electrons, I would do the same thing. 1, 2, 3, 4, 5, 6. So the types of multiple choice questions you're going to get, just so you know, is we're going to ask you like, what is the configuration for 6 electrons? Which one is the correct orbital diagram? And one of them will look like this, and one of them will look like this. And if you select this one, I know you forgot to fill each one first before their own. That's how I catch you. Does that make sense? Like that's what they're going to be looking for. So that's why I said, make sure you fill in the right order so you never have to think about it. Okay. All right. I want you guys to try on your own to do 17 electrons. 17 electrons in this diagram. Okay. 17 electrons. So you're going to need to draw up to 3p on your paper. So draw up to this and then fill 17 electrons. And Darshan, I'm going to have you help me start because I'm having you come back to that, but then I'm going to have other people help me. So he's not going to be the only one. I didn't forget. All right, tell me how you did it. Darshan, start by telling me how you filled the arrows here.
So for 1s, I did 1 up and 1 down, and then
Okay.
same for 2s.
Yep, okay.
So that gives 4. And then for 2p, I did 1 arrow up on the first dash, 1 arrow up on the second one, 1 arrow up on the third one, and then I went back and filled the down arrows for each
Well,
blank.
that gives me 10. Okay.
Then for 3s, I did 1 arrow up, 1 arrow down.
Well, that gets me to 12. And now I have 5 more.
So I did 1 arrow up for each one, and then 1 arrow down for the first 2.
Yep. And that would have been correct. All right. Thank you so much. You did a great job. Akshar, how would I do that on the periodic table? Say I don't have this in front of me. Say, and I have to build it for my test. How could I check it with my periodic table that's in front of me? Talk me through the up and down arrows.
The first one you'll go up and then down.
Okay, and
And
then,
one up and then down.
okay.
And do the same thing for the rest of the row.
Okay, but would I go up, down, or would I go up, 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 down, down, down?
And you go up first and then you go down.
So up, up,
Like
up.
3 times up and
Yep.
then
I was tracking what you meant. I filled in the lines there. You're doing a good job. And then what do you do here?
And then you do up and down.
And
And
then,
then you do up, up, and up. And then 2 down.
yep. And notice that matches exactly what he put here in numbers of arrows. Okay, so you can do this every way. So this is the element chlorine, and the configuration you can see right here. We have 1s2, 2s2, 2p6. I'm trying really hard. 3s2. Why is this happening to me? And then 3p6. Good Lord, that is nasty, but you guys can see it, right? 3p6. All right. So now I want you to draw the whole thing all the way up to 4F. Go ahead. I'm going to give you a second to draw that right now.
This Longley, was it 3p6 or 3p5?
It was 3p5. I just totally, the mouse is throwing me off. It was 3p5 because it's in the 7th group, 7A. All right. Once you draw that, okay, you guys are going to do 84 electrons. And this is what I want you to do. Okay. You're going to give me the arrows. So the orbital diagram. You're going to give me the configuration, full configuration. And then you're going to give me the noble gas notation, which is the shorthand I just taught you. Wow, that's really bad. See how bad this is? Okay, so you're going to give me the arrows, the full configuration, and the noble gas notation, where you go up and to the right and then just do the last line. Okay, arrows, full configuration, noble gas notation for 84 electrons. I'm going to put you in groups. Okay, so if you aren't ready yet, please don't go yet. I'm going to put you in groups of 2 to 3, depending on which room you end up landing in. Okay. And you guys are going to work on it. When you come back, I'm just going to start calling on people. Okay. So it's not going to be any wait time. It's going to be like, boom, go. I'm going to give you guys 5 minutes, full configuration, noble gas notation, and the orbital diagram with the arrows. Okay. I highly, highly recommend, I'm going to put this image on a PDF for you guys, and I'm going to email it out. If you want to print it and put it in a page protector, so you can do this with an expo over and over, that is literally what I normally do. Like if you guys were here in person, I have a binder of reference materials that I keep in page protectors. And at the beginning of class, you come up, take one, and then you go in, like they're sorted by like periodic tables, orbital diagrams, thermochemistry, whatever. And so you guys have manipulatives you use every class that with expo markers. Like I go through so many expo markers, it's stupid. So yay, recycling. But yeah, if you guys want to do that at home, please let me know. I'm happy to help provide page protectors or printouts of things. If you don't have access to a printer, you just have to email me and I'll put them at the front office, okay? I also have already printed Unit 4 notes packets for some people because I've done that for some people in the past. So if you want those, let me know, okay? So I'm gonna put you in your rooms, 5 minutes. It's open, only go once you're ready. Arrows, full configuration, noble gas notation. Last thing of the day. All right, Eden, let's start with you. We're going to count the arrows on the left first, orbital diagram first. All you got to do is tell me up and then down. Okay, so what do I do?
Okay, so you're going to start off with up.
Okay,
and then down,
that's 2.
up, and then down,
That's 4.
up, and then down, and then up again,
There you go.
and then up again. And then I went back and put down arrows.
Okay, so that gets us to 10. All right, I'm gonna have someone else help me with the next part. Thank you very much. Kai, what do I do now? So we're at 10 so far. Gonna keep track.
You have another up arrow.
Yep.
And then a down arrow.
Okay.
And then you do an up arrow, and then another up arrow, and then another up arrow. And then you do a down arrow, and a down arrow, and a down arrow.
And then what do I do for 4S?
And then you do an up arrow, and then you do a down arrow.
Right, so that puts us at 20. Okay, we're getting there. All right. Next. Faisal, what do I do now?
Okay, so for 3D, there's an up arrow, and then another up arrow, and then another up arrow, and then another one, and then another one, and then you go back and put down arrows for all of them.
Yeah, you can just say up. I know what you mean. So that gives me 10 more. So that's 30. So that jumped up quick. So see, it took a long time to get to 10, long time to get 20, and now all of a sudden we're at 30. All right. And do 4P for me.
4P is, again, up, up, and then another, and then down for all of them.
Yep. So that puts me at 36. Okay. Now, next person. Sneha, keep going. Where do I do now?
So then you would do an up arrow.
Yep.
And then a down arrow.
Okay.
And then up, 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 and then down, 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 down. Wait, I lost count. I think it's also down.
There we go. Yep. So we can look to what we're pairing up. So it's 36. So we have 38 and now we have 48. Okay. All right. Thank you. And then next for 5P, Corey.
You do an up, another up, and one after that, and then 3 down arrows to match them.
Yep. Down, down, down. And then 6S.
Up and then down.
So we're at 56. Okay. Now, Maddie, give me through 4F.
Yes. And for 4F, I put up, 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 and then down for like all of them.
Yep, paired them up with their downs. Good. We're practicing doing them in the right order. So that's 14. So that puts us at 70. Okay. You actually needed more lines, right? So if I was going to build more lines above this, see what I did do? I made you have to look at the periodic table to build it. So how do I build the next one? What comes after 4F? So we just did this. So what should be my next set of lines? Izan.
It's 5D.
And how many lines do I draw?
You draw 7.
For d orbitals?
Oh, 5.
Yep. 1, 2, 3, 4, 5. Why is it 5?
I don't know why it's 5, but
Because there's 10 electrons possible in D and they have to occur in pairs. So if I have 10 people and I have to pair them up, that gives me 5 couples, right? So if I have 10 electrons and I have to pair them up, that's 5 couples of electrons or 5 orbitals. Okay. So how do we do the arrows now?
you go up, 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 and then up, and you go down, 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 and down.
Right. So that gives me 80. We're almost there. I only have 4 more. So what do I write last? Shanmati, what do I write last?
6P.
Beautiful. You did the number and the letter right. How many orbitals do I draw?
3.
1, 2, 3. And how do I fill those arrows? I have 4 left.
You go up,
Okay. Up,
up,
an up, and one down.
Yep. And that would be it. So guess what element that was? It was PO, what we started with in the beginning. It was the very first one you did. Full circle. So now you understand how to fill the arrows. You understand how to write the configurations. We know how to identify it. It is 6P because it's in the 6th line. So this is 6. So this is 6S, 4F, 5D, and 6P. That's why the number goes back up to 6 for those of you that asked. Okay. So that would be it. For the configuration, we did that the first time. So it would still be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, etc. Because it's the same thing as here, right? You would just be writing this out with numbers. So the last thing I really want to ask you, since we've already done this configuration, you should have seen it. Samir, how do I do the noble gas? So if this is PO, and
Yeah.
we have, I'm gonna give you these two. This one's xenon and this one's
And-
radon. How do I do it?
Okay, so the way you do it is you go to the last noble gas that you passed. So that would be xenon.
Yep. So
And
xenon.
yeah, you put it in the hard brackets, and then you would go everything afterwards. So you would have 6s2, and then you would have 4 F10 or 14, sorry.
There we go.
And then you take 5D10,
Okay.
and then you would have, that's right there, 1, 2, 3, 4. So then that would be 6P4.
Beautiful. Isn't that much better than what we wrote the first time?
Yeah, easier.
Yeah, so much better. Okay. That's everything for unit 3. Dunskies, Dunzos, you did it. Locked in the brain space. I do want to show you one thing. Okay, so on your flame test, okay, I'm just going to tie in an old topic since we have about 30 seconds for me to do so. When you had sodium, okay, sodium is here, right? So that was the same as 1s2, 2s2, 2p6, so we fill it, and then 3s1. So what happened when they put the sodium in the flame, the salt, okay? This electron jumped up to a higher orbital. So it looked like this. On a test, you would, if I gave you this as a possible orbital diagram, you'd have been like, nah, dog, that's not fair because we're going from low energy to high energy, right? But what happened is that the heat energy made this electron in the valence shell go crazy. Like it absorbed all the energy and moved away from the nucleus physically, okay? So when you see the color is when this guy, like all the caffeine and heat energy or whatever analogy you want to use, leaves his body and he comes back to where he's supposed to be. That is when we see the color, and it was yellow, okay? It's because it jumped, and then when it relaxes, it's emitting the color. That's where the energy is coming from. Now that you've seen this, I just wanted to tie that back in for one last little full circle, okay? So you have QC 3.2. You've got electron configuration activities if you didn't finish them. And you have the test review to do, or the quiz review to do as homework, okay? Do the pre-test, do the quiz review, do it, do the thing, win the stuff, get the grade, get the prize, okay? You guys did so much better when more of you did the pre-test. Please don't neglect it. It is still an assessment, okay? I will be here if you need me for tutoring, but if not, sayonara. I will see you in 48 hours.
Miss Longley, could I take my quiz during 4th period?
Yeah, I have IB that period. So we'll be talking stuff, but you can just mute your computer. And or you can just hop in and I'll give you the code and you can have your video running and just mute your computer so you can't hear us talking if you want.
Okay.
Does that work for you?
Okay.
Okay.
Yeah.
All right, cool. All right, what up?
So, well, if you had beryllium, and you wanted to write the noble gas configuration, you could use helium for that, right?
Yes, because technically it's a noble gas. That's why it's on the right side. Its valence shell is full. It's just a weird valence shell.
Okay. And then also when you're doing the F shell, so lutetium and lawrencium are supposed to be part of the D.
Yeah, so the way this periodic table wrote it is that the last one in line is the one that's here. Because if you look at the numbers, so look at the number on the block. See how it says 71? There's got to be something here. It's not like there's no element here. So the one that's there is 71 because this one's 72. So it has to be 71. A lot of periodic tables actually physically write this here and just have a little line. But every time I've used that one to teach it, people skip the line because they're like, it's just a little bit more bold. Like their brain doesn't see it like they do an empty block. If that makes sense. So this has been the more successful way.
So both lutetium and lawrencium are like both part of F and D shells then?
They're part of just D. They're just part of D. They just wrote them down there because so they could leave this part blank. That's why I always cross them out. And I'm like, nope, they're not here. They're D.
Oh.
They're transition metals. 71 and 103 are transition metals.
Okay.
Sound good?
Yeah. And then, one last thing. I'm just curious, but do people ever use noble gas notation for if they just want to write like the configuration for a noble gas? Or do they actually...
You technically are not supposed to do that, but I've seen people try to get away with it. Like I will never ask you guys one of those. But the reason, so this is why that won't happen in real life. The reason we use noble gas notation or we use electron configuration is to show which electrons are shared in which orbitals. Since noble gases are inert, they're not really going to be a part of compounds. That makes sense? So I will show you electron configurations again when we do bonding in Unit 4, and you'll see why. But technically, yes, but we wouldn't need to.
Okay, thank you.
No problem. Anyone else?
I have a quick question on finding the valence electrons when given the electron configuration.
It's adding up S and P of the highest number.
Oh, okay.
Yeah, so if I go back to this one, erase all ink on slide. Okay, S and P are the valence shells. So once you have like 4S, right? None of these matter. This is now the valence shell. So it's the highest, even if 3D exists. 3D has more energy, but it's not valence. It's only S and P.
Okay. Thank you. That made a lot more sense.
Yeah, 2 + 6 is 8. That's where the valence shell comes from.
Thank you.
No problem.
Have a great day.
You too.